Here we are asked to complete the tables for the geometric sequences, graph those points on the graphs below. So note that some of the points aren't going to last on the graph because they get to be really big numbers here. So in this case here, I know it's geometric. So in this case, I'm not adding 3, but I'm actually multiplying by 4 each time because, again, geometric sequences, we got to know our multiplication. In the second one here, to get from 3 to 6, I am not adding 3, I am multiplying by 2 because, again, geometric. So completing these tables, 4 times 4 is 16, 16 times 4 is 64, table completed. Now graphing, my initial term 0 is 1, and then my first term here, my initial value is 1, my first term here is 4, so 1, 2, 3, 4. My second term is 16, so 2, 3, like right there. My third term is 64, which goes off the graph. I also don't connect these dots because when we're talking about sequences, we're talking about the number of terms here. We're not going to have a 0.5 term. We're not going to have half a term. We're just looking at the first term, the second term, the third term, so those land on exact points. Same thing with the second one here. We're multiplying by 2, so we get 12 and 24 to complete the table. Then graphing that, this one here is starting at the first term. So when n is 1, my f of n is 3. When n is 2, my f of n is 6. When f is 3, f of n is 12. So 1, 2, 3, 4, 5, right there. And then 4 is 24, which ends up being off the graph somewhere up here. And again, we're not connecting those. So really what we're looking at is our x values are represented by n, or the inputs, and our y values are represented by f of n, or what comes out when we plug in a number. So there's our completed tables as well as our graphs. You notice these are not linear because it's a geometric sequence, not arithmetic.